Okay. We're talking about 2-7 parent functions and transformations today. I don't think you guys have ever done this before, or if you have, it's not been done this way. So a parent function is like, so let's think about your parents, right? So like my dad is blonde hair, blue eyed. I have blonde hair and blue eyes. My mom is like 5'2", I'm like 5'10". So obviously I got a bunch from my dad, right? But I still look like my mom too. So my parents are like the original, and I'm obviously they're a baby, right? So a parent function is like the original, and we're going to move it and change it and morph it, okay? So we're going to have a parent function that's the original graph that we're going to memorize, all right? And then we're going to move it up, left, right, down, flip it, all sorts of stuff, okay? So let's just start by filling in the blanks. A family of graphs is a group that displays one or more similar characteristics. Okay? So for example, y equals x squared is a parent graph that we're going to memorize in a second. And y equals x squared plus 2 looks the exact same, but it moved somewhere. Okay? A parent graph is the graph of the parent function in simplest form. All right, a constant function, f of x equals a. What's f of x fancy for, by the way? What's f of x really? Just a y, right? So if I have like y equals 7, okay? It's just a horizontal line, isn't it? That's a constant function because it's just a constant. It's just a 7. There's no variable there, all right? So where a is any real number, like I just said 7, your domain is all real. That's what negative infinity to positive infinity means. And your range is all real. So what am I? Oh, it's a horizontal line is what we're missing. Horizontal line. And I would even graph that for myself and be like, oh, here's what a constant function looks like. Okay? And on the back, I think, is where I kind of put them all together as a graph. So we'll fill that out in a second. Do you guys have a back? Is there, or is it not blank? Is the back side blank? Yeah, we have room on the back. Okay, so we'll do that at the end. Remind me to do that. All right, identity function y, or f of x, equals x. It passes through a comma a, so like 2 comma 2, 3 comma 3 or something. Again, domain and range is all real for both of them. It splits, what do I want to say there? Hold on, it splits quads. I'm assuming 1 and 3 is what it means there. I don't know what that means there. I didn't type this one up, and I don't have a blank for myself. So we'll come... Oh, no, I have it right here. Just kidding. 1 and 3. I was right. Sorry. Quads 1 and 3. I'll show you what I mean in a picture. So if we have... Which one was this? Identity. If we were to graph that, it looks like this. It goes through 0, 0. And then we've got like 1, 1, 2, 2, 3, 3. So you guys see how I'm in quadrant 1 and quadrant 3? So here's quadrant 1. We always go counterclockwise. Here's 1. Here's 2. Here's 3. And here's 4. But when I move it, that's not true anymore, okay? Absolute value function, f of x equals absolute value of x. You guys have known that for forever. The domain is all real again, so negative infinity to infinity. The range is y is greater than or equal to 0. And what shape does an absolute value function make? Everything so far has been a line. What's an absolute value make? A v, right? Absolute value has a v, it makes a v, okay? V-shaped. Everybody okay with that? So that absolute value function, I'm just going to graph it here real quick. Make that a real sharp V. Okay? And again, we'll make them prettier on the back. Don't worry about that yet. Quadratic function, f of x equals x squared. Your domain is all reals again. And y is greater than or equal to 0. It's a U shape. Quadratic is a U shape, which you guys did in Algebra 1. It's been a while, but you did do it. Okay? So all of those graphs are down here. This is my constant function. It's a horizontal line. This is my identity function. This is absolute value. It makes a V. Any absolute value graph always makes a V. It's just moved, right? This is my quadratic. So here's how I remember it. Absolute value has a V. It makes a V. Quadratic has a U. It makes a U. So that kind of helps, okay? All right, translations. It can move a figure up, down, left, or right. So we're going to take like x squared and move it up 4 or something like that. So if you know the parent graph, you can graph it like way quicker than in Algebra 2. In Algebra 2, you guys had to find the vertex, and you had to do a t-table, and you had to do like extra points and everything. So if you know these tricks, they take way less time and they're a lot quicker, okay? When a constant k is added or subtracted from a parent function, the result, f of k plus or minus k, is a translation, where am I at? Up or down. That's what they're looking for. Up or down. I've never filled in the notes before. I've only ever given you the info, so I'm trying to figure out what I'm missing for you. So again, all this information separate looks really daunting. At the end, I'm going to shove it all together and like show you that way instead. So we're just going to do one thing here right now. A reflection flips a figure over a line called the line of reflection. So by now you guys know, if you go back to Algebra 1 for a second, like if I was graphing y equals x squared, you guys should know that it looks like a u like that at 0, 0, okay? If I was changing it to y equals negative x squared, do you see how it flips it over the x-axis? That's what a negative is going to do. It's going to flip it either over the x-axis or the y-axis. Again, I know this is a lot of info. When I get to the questions, you'll see what I mean, but I'm just trying to show you as I go a little bit. When the parent function is multiplied by -1, the result is flipped across the, which one is this? This is the x-axis. Okay? When only the variable is multiplied by -1, it's flipped across the, obviously, y-axis. And again, I'll show you guys that better when we have examples. It's easier to tell. Okay? Is this the next one? All right, dilation. It shrinks or enlarges a figure proportionally, just like when you get your pupils dilated at the optometrist, right? They get bigger or smaller depending on what they're doing to you. So when the variable in a linear function is multiplied by a non-zero number, the slope changes. When a nonlinear parent function is multiplied by a non-zero number, the function is stretched. I have greater than 1 here, or compressed if it's in between 0 and 1 vertically. Again, that is a lot of information, so this chart kind of shoves it all together, but I do it even more simplified than that, so give me a second here. This is just a summary. This is saying everything we said, but it's all like together, okay? Let's go to the back and put this a little bit prettier. Yeah, I think we have space on the back here. So go to your back page, and I want to do this. I think this is nice to have. We already have all your graphs. I think that's fine. Let's do it like this. F of x, you guys have space on the back bottom, right? I don't need much. F of x equals -a x minus h plus k. I know this looks really scary. Once you get it, though, it's so easy. This is the way I taught it when I taught pre-calc. I just kind of shoved it all together because all those different things, I feel like it's kind of overwhelming. So here's what we're going to do. If we have something like y equals x squared plus 2, like that's kind of what it's saying, okay? If we had something like that, anything here at the back, basically, anything adding or subtracting just a constant, if you do this, it's going to go up or down, same as your sign. So if I have y equals x squared plus 2, that means I'm going to move the graph of x squared physically up 2 spaces. Everything else is the same. Okay? If I have something inside of grouping symbols, whether it's parentheses with a square, whether it's, eventually we'll get to a square root sign, absolute values, anything like that, those go left or right, and they go opposite of the sign. So again, if I had like x minus 2 quantity squared, that means I would move everything right 2. Okay? A is a dilation where it gets fat or skinny. And we're talking about graphs, not people, so we can say that. Okay? And then if I have a negative in front here, this is a flip. This is all exactly what I said before, but like super condensed. Okay? All right, so let's go to the first example. Am I on this page? Yeah. All right, identify the type of function represented by each graph. So they just want me to tell them if it's a constant, an identity, a quadratic, or an absolute value. They just want me to tell them which kind it is. So all we're doing is looking at the shape. I don't care how, if it's upside down, flipped, skinny, fat, it doesn't matter. I'm just looking at the shape. So what shape is letter A? It's a U, so what does it have to be? Quadratic. That's how easy that is. Good. Quadratic. Excellent. What shape is letter B? A V, so it has to be absolute value. Excellent. All right, letter C is obviously a line, right? So it's not quadratic, it's not absolute value. Now our question is it identity or is it constant? So if it's a constant, it will always be a horizontal line with no slope. Literally, it's a zero slope, right? So if it has any slope at all to it, it's the identity function. So this one's obviously identity. Do you guys get the difference? If it's horizontal, it's constant. If it's not, it's identity. Anybody still need that? Okay. Example 2, describe the translation in each function and graph the thing. So we're going to say what's going to happen, and then we're going to do it. So I'm going to graph my absolute value function, but it's going to move where 3. So if you go back to that thing that I had at the back, you don't have to flip it, but this thing, okay? Do you guys see that it's the -3 is this guy? Because it's not inside the grouping symbols. So that's going to mean either up or down 3. Which way is this going to move? Up or down 3? Down 3, exactly. So don't graph what I'm going to graph right now. I'm going to graph the original. The original absolute value, if you aren't like catching what I'm saying, if I were to graph just the absolute value of x, the parent function, which we're going to have memorized at some point, this would give me 1, 0, and 1. So it would look, that's really small, but like this. This is the parent function, okay? I'm going to move that exact graph down 3. So instead of at 0, 0, I'm going to go down 1, 2, 3. And it's going to be the exact same graph. So you don't have to graph the parent one. I do need you to graph the other one, though. The whole point of doing these is so we don't have to do a t-table. Could you guys graph that if I gave you plenty of time in a t-table? For sure, right? But eventually we got to do it quicker. Okay? So you're literally just going to do 0, -3. And then if you want to be more specific than that, it would be 1, -2, and -1, -2 as well. Okay? So what I would have said is it goes down 3. That's the describing the translation for me. So I just literally draw an arrow down 3. That's fine. You could write goes down 3. That's fine too. Okay? For this one, it's not absolute value. Do you guys get that? It's not quadratic because there's no square. So it's either a constant or it's an identity. Which one is this? A constant would just be like y equals 4. So it's not constant, right? So it's obviously identity. So that's the one that looked like this. Went through the origin and had an up 1 over 1 slope, right? So this one, pretend you don't remember algebra 1 for a second and you couldn't graph it on your own. This just moves it down 1. The whole graph goes down 1 from the original. And it has an up 1, right 1 slope again. But it's the exact same thing, but down 1. Is that okay? So again, if I'm describing it, I would say down 1. Okay? All right, on the next one, describe and graph again. What shape is this going to be before I get too far? What shape is that going to make? A line, a U, or a V? A U, because it's a quadratic, right? So my parent graph of x squared looks just like this right here. 0, 0, 1, 1, -1, 1, but a U instead of a sharp V. So it's essentially the absolute value graph, but it's a U instead of a V, right? But that negative sign in front of the x squared flips it this way over the x-axis. The flipping gets tricky because sometimes you can't tell if it's over the x or the y-axis. It does get kind of tricky. So if you did have to do a t-table, I want to do it with you even though eventually I don't want you to do that anymore. I want you to actually see where it comes from. If I were to put 0 in, well, 0 squared is still 0. Like, that's easy, right? If I put a 1 in, what's 1 squared? 1 with a negative still hanging out. -1, right? I'm only squaring the x. If it said this, I would have a different answer, but it doesn't. Do you guys see what I'm saying? So this time I'm going to square the negative 1. What's negative 1 squared? Positive 1, with a negative still in the front. So if you really freak out on a test or quiz and you can't remember which way it flips, you could do a t-table really quickly, but that's not the goal in the end, okay? So I'm just going to have 0, 0, 1, negative 1, and negative 1, negative 1. It's the exact graph. This is the parent graph right here, okay? And it's flipped over the x-axis. Do you guys see that? Okay? On this one, what shape am I going to have? A V, because it's an absolute value, right? So I'm going to graph the parent function really quickly. You don't have to. I'm just trying to show you. It's at 0, 0, 1, 1, negative 1, 1. You're going to have that memorized eventually, okay? If I'm flipping it this time, this is where it gets confusing on whether it's over the x-axis or the y-axis. I'm going to show you. If it had been like this, which is like that one, because the grouping symbol I didn't square the negative. Do you see what I'm saying? This would be exactly like the one before it. But because it's inside with the grouping symbol, it's going to be the opposite. It's going to flip over the y-axis. But I want to do a t-table so you believe me. Okay? Eventually, we're not going to do that anymore. So negative 1, 0, and 1. If I put 0 in, absolute value of 0 is still 0. I don't have to think about it. If I put a 1 in, and then a negative, and then absolute value it, what do I get? Positive again, right? 2 negatives make a positive of the negative 1 here, and positive again. So do you see that I ended up with the exact same graph back? So that means I flipped it over the y-axis this time. So my answer is the graph that I first started with. It's actually the exact same graph. Are you following this? I know it's a lot, but are you at least following what I'm doing? Okay? I'm not saying can you do it on your own yet, all right? With these, even when we get good at them, these are dilations. Do you guys see how there's a number in front of the x's? So it's going to get fat or skinny. With these, I still do a t-table just because I'm not sure how fat or how skinny it's going to get. These two are easy because it's 2.5, so we kind of can figure those out. But sometimes it's like 3 or a 1/9 or something crazy like that, and even I'm like, I don't quite know where that would be. So I still do a t-table even though I know what's supposed to happen, so I can be more specific and show how fat or skinny it's getting. Okay? So what shape is this going to be? A V, absolute value, right? We forgot up here to describe it. This was a flip or reflection over the x-axis. Sorry, guys, I'm all over the place. And this was a flip or reflection over the y-axis. I forgot to describe the translation. And this one we already know is they're both dilations, but I want to be more specific in a second. I'll show you which kind they are, okay? So we're going to do a t-table. Again, just like negative 1 to 1 is fine. So if I put in 0 first, what's 2 times 0? 0, absolute value, 0. If I put a 1 in, what's 2 times 1? 2, absolute value, 2. 2 times negative 1, negative 2, absolute value, 2. So if I graph that one, my original graph is 0, 0, 1, 1, negative 1, 1. This one's going to be negative 1, 2. You actually do want to graph it. When we do ours, our graphs will be a little bit bigger and easier to see. Sorry. So negative 1, 2, 0, 0, and 1, 2. Absolute valued. Okay? So what actually happened was if I graph the parent graph for you, do you guys see that this actually got skinnier? Mine's the dotted line, yours is a solid line. So this actually got skinnier. So fraction, if not a fraction skinny, what's a fraction going to do? Fat. We're just going to get fatter, right? So if I do x squared, it's supposed to be right here, 0, 0, 1, 1, negative 1, 1, a nice, pretty smooth U, okay? So this is going to get fatter by double. Even though it looks like half, it's going to get fatter by double. But let's do a t-table so we really believe it, okay? You could do negative 1, 0, 1 again, that's fine. If I do 0, 0 squared, 0, 0 times anything, 0, that's still fine. If I do negative 1, what's negative 1 squared? 1 times a half. A half. If I do 1 squared, it's 1 times a half, it's a half. So if you guys look, I know it's hard to see on this one. I'm going to make it bigger. That's hard to see. I don't like that. if I do 0, 0, 1, a half, negative 1, a half, nice smooth curve. If I graph my original, it was at 1, 1, and negative 1, 1. Do you see how mine got fatter? Fraction fat, fraction fat, fraction fat. Okay? Are you following this? We're going to get a lot faster eventually. All right, example 5, write an equation for the function. So first we have to decide what this is. What shape is this? A line, a U, or a V? A U. So what type of graph do I have? Constant, identity, quadratic, or absolute value? Quadratic. So I know that I'm going to start with y equals x squared. It's going to be some form of this. Do you guys get that? So now I have to say, okay, my original graph is at 0, 0. Where did this one move? Up how far? Look at yours. It might be easier to see. It went up 1 full tick mark, right? So if this thing moved up 1, if I go back to my rules, up 1 is at the end by itself, and you do the same as what you want. So if I want up 1, is that a plus 1 or a minus 1? That's a plus 1. Very good. Did it go left or right anywhere? Here's my original, 0, 0, 1, 1, negative 1, 1. Did it go left or right? If I started at 0, 0, and it went straight up. It didn't go left, it didn't go right. Do you guys get that? And it doesn't look like it dilated. I don't think it got any fatter or skinnier. It looks the same to me. So that's our answer. We're done. Did you at least follow that? Okay. I'm going to add a couple of examples because I think we need more, because it's just tricky in general. We're going to take a lot of time on this section, okay? So let's add this example wherever you have space. It's just like 2 examples I want, okay? I'm going to give you the equation, and we're going to draw it. We're just going to sketch a graph. Okay? We're going to sketch a graph. These are called sketching graphs because I'm not being super specific. For the most part, I'm not doing a t-table. I'm just finding the vertex and moving it. Okay? What shape is this going to be? A line, a U, or a V? A U, because it's a quadratic. Do you guys see that square? Okay, so it's going to be a U. So I'm going to tell myself this is a U, all right? Where does this move? So it's not at the end. It's not the K. So it's not the up and down. It's inside the grouping symbols. So that's our left or right, and it's the opposite of what we think. So if I see a -2, like I would think left 2, but it's the opposite. So it's going to be where? Right 2. Okay? So my U that's normally right here is going to move right 2, because that's the only thing that happened to it. It didn't get fatter or skinnier. It didn't flip, nothing like that. It's just a U to the right 2. Do you guys see how easy these can be? Okay? Let's try another one. Let's do y equals negative absolute value x plus 1 minus 4. That's a lot, okay? Here's what I ask myself first. What shape am I going to be? A V, because it's absolute values. Very good. I'm just going to write myself a little list, okay? It's a V. Where does this move? Down 4. Up or down, whichever way it says. Where does the 1 move? Left 1. What's the negative outside the grouping symbols do? It flips it over what? The X or the Y? The X. It flips it over the X. Okay? So, my original graph, don't graph this yet, my original graph looks just like that. 0, 0, 1, 1, negative 1, 1. But I'm not going to do that, okay? This is just a sketch, right? I'm going to go left 1, down 4. So left 1 and down 4 would be right here. That's my vertex. That's the most important one. If that negative sign wasn't there, it would just be like this, a V going up, right? But there's a negative sign, so it's opening down. If there's a constant somewhere, if I had a 2 in front of the X or something, I would have to do a t-table because, again, it got fat and skinny and I don't really quite understand where it would go. But everything else, I don't need to do a t-table. Just find your vertex and move it. and graph the thing. Did you at least follow what I did? Pick a shape, move it wherever it goes, graph the thing. Okay, let me end this, and then if you guys have questions, you can ask me.